A pyramid has a square base with a side length of 210 feet and a height of 15, where the apex is directly above the center of the base. Set up a definite integral to find the volume of the pyramid. Use horizontal cross sections. Okay, so here we have a picture of it, and it says the side length is 210, so this is 210. This is also 210. The base, and the height of the thing is 15. So all the way from the tip top straight down to the apex, which is well, the apex is up here, and it's right over the center of the base. That's 15. Now, um, horizontal says use horizontal cross section. So you can see this horizontal plane right here is cutting through right here, this horizontal cross section right here. And it produces a square, right? Because the base is a square. It's a square base. So this as this horizontal cross section rises up through the pyramid, it's always gonna be cutting out slices that are squares. Well, they're square pieces like that, aren't they? They're gonna have a thickness to them, and the thickness is gonna be dy. Let me put that in there for us. Well, let's just indicate it this way. dy is the thickness. Yeah, there we go. So there it is. So that thickness is dy for each of those slices. And so we're going to need to integrate, oops, from 0 to 15. As you can see, the integral is there from 0 to 15, because we're integrating y values. This is y equals 0 on the bottom. This is y equals 15 at the top, right? And each of those is going to be the area of the square times the thickness dy. That'll give us, this will be overall the volume of the slice. We're trying to find out the overall volume of this pyramid. That's the goal. Calculate to find the volume of the pyramid. Volume of the pyramid. So we're going to add up. That's a big S for the sum. We're going to sum up, add up the volume of each of these slices. And each slice, like this slice right here, has an area of the square times the thickness dy. Now, what's the area of the square? It's one side times the other. Let's call it W. It's going to be W squared times dy in the integral from 0 to 15. Now, what is the width? That's the real trick. How do we find the width? This is a square, so it's W squared. How do you find that width? Well, you do a similar comparison. So what I'm going to do, I'm going to come over here and I'm going to go the height above to the base is the height above to the base. And so the overall, so what's the overall? So here's the base, 210 of the overall thing, and the height above it, the line going above it is 15. So 15 over the 210, that's for the whole pyramid, right? The height above is 15, the base is 210. Now compare that to this. The height above is going to be 15 minus y over the base, which is the width. Do you see that? How do I know? Well, this is 15 all the way, and this slice is up at a height of y. It's up at a height of y. If that's up y, if this is 15 all the way to the top and it's y up to our slice, then the part that remains is 15 minus y. It's the whole thing. It's the whole 15, take away the y. That's this part here that remains. 15 take away y. You see that? That's the hard part for people to do on this one is get that straight. So we're going to be taking slices from the bottom and going up, horizontal slices. And you can see this one slice that's up at a height of y. So when a slice is up at a height of y, um, then the part above it is 15 minus y because the whole thing is 15. Take away the y, this is 15 minus y. And so height above 15 over 210 is height above 15 minus y over w, the width of the slice. And so we can use that to now cross multiply. I'll bring it over here and solve for w. So we get 15w is 210 times 15 minus w, just cross multiplied. And I'm trying to solve for w. So divide by 15. Use your calculator, that'd be what? 14, 15 minus y. So that's w. So then this integral becomes integral from 0 to 15 of w squared, 14, 15 minus y, the whole thing squared because it's w squared times dy. There we go. There's the integral we needed to set up. I know they wrote it a little different, but it's the same thing. That's the integral. And we're just going to stop right there. We're just setting up the integral that would calculate the volume of that whole pyramid. So again, how did we do it? We just said we're just going to need to add up these slices. Here's one slice at a height of y along y as y goes from 0 to 15, right? Y is 0 at the bottom, 15 at the top. And we're going to sum up the slices as y, dy is our letter, as y goes from 0 to 15. Y goes from 0 to 15. And whatever your height of your particular slice is y, we can find the width and thus the area of that slice. How do we do it? 15 all the way up, and it's 210 on the base. So 15 is to 210 as 15 minus y is to w. There's the trick on that one. We can cross multiply and solve for w and then plug that in. So that's the trick most people have trouble with. So spend some time thinking about that. Again, this is similar triangles, or in this case, similar pyramids. This is like a little pyramid, and the whole thing is a big pyramid. It's a similar shape. So again, it's 15 all the way. It's y up to our slice. So that's 15 minus y is the rest of the way. Because again, it's 15 all the way. Take away the y in the bottom. This is 15 minus y. So then there we go.